Let us create an assembly of pipe vise. So let us insert the parts. So before that, just try to create a new assembly document. So you can press new, say press assembly and say OK. So here I'm going to create a sub-assembly first, sub-assembly of a handle. So later you can complete the total assembly. So I'm going to insert handlebar cap and screw rod. So you can just hold control and select the handlebar cap, handlebar and screw rod, say open. So you can place these parts just by clicking on the graphic window. So let's place the parts. So since I inserted this handlebar as my first part, so this is fixed, so it won't move. And if you want, you can move the handlebar cap and the screw. I want to float this handlebar, so I want to move this. So right click on this and just say simply float. So now I will move this part. So let us fix this screw rod such a way that the origin of the screw rod is having a coincidence relationship with the origin of the assembly. So I want to move this. So go to hide and show items. So you can highlight the view origins. Okay, so I selected this view origins. So here you are able to see the origins of all the parts. So let's apply mates. So initially I want to fix this screw rod in such a way that the origin of the screw rod is in line or is coinciding with the origin of the assembly. So let's apply mate, pick the origin of the screw rod and the origin of the assembly and apply coincidence relation. See that this align axis is toggled on. Say OK. Now apply relations between the screw rod and this handlebar. So I want to select the outer surface of the handlebar and the whole surface here, and let us apply concentric. Say OK. Now this can move like this. So let's add relation between this cap and this rod. So just I want to move this. So again I want to select this surface and the surface of the rod, external surface of the rod, and add a relation concentric. Say OK. And I want to select this circular edge of the rod and the circular edge of the cap, and I will apply coincidence relation. Say OK. So now the cap is fixed to the handlebar. So since I want to have another cap inserted over here, so I want to just mirror it. So I want to close this made property manager. Say OK. So click mirror components. So you need to select the mirror plane here. So I'm going to mirror this cap with respect to the right plane of this rod. So let's select right plane as the mirror plane, and to select the components, so you can select it from the graphic window, or you can do it from this feature tree. So let's select, I want to pick it from the graphic window, so just select this part and say OK. So here if you see, this rod is coming out of this, so I want to restrict the movement of this rod such a way that so it shouldn't come out of that from this hole. So since you have two caps which are meant to restrict the movement of this rod, so let us apply mates. Select mate. So let us use advanced mate to define the limit of this movement. So let's pick distance mate. So before that, you can select two different surfaces so that you can apply limit mate. So I want to select the right plane and this surface as the references. So let us define the minimum distance and the maximum distance. So here you need to define the you have to allot the assign value of something to to define the maximum value, and here you can add the minimum value. So let's move this. So I want to just move it, say 12. So here, so actually this is just touching this, the cap is just touching the head of this screw. So I want to just for my convenience, I want to leave some clearance here. So instead of going for 12, so I will allot or assign 13 mm here. So I'm going to fix this as the minimum distance between these two surfaces or these two references. So allot a value of say 13 mm as the minimum value. So move this bar to fix the maximum value. So I want to allot a value of say 100. So still it can move, so you can increase the value, say 105. So I want to increase this, say 108. So let us allot a value of 108 as the maximum limit. So here I want to fix it as 108 and say OK. So let's close this mate. So if you see here, the movement of this bar is restricted, and so still it is rotating, but the movement is restricted. We are finished with the sub-assembly of this handlebar. So you can save the file, save the assembly file. So I'm naming it as handlebar assembly. Create a new document for pipe assembly. So click new, select assembly and say OK. So browse the parts to insert. into this assembly document. So I'm selecting Y's base. So just hold Control to select multiple parts. So insert all the parts. So these are the different parts that that we modeled. F in the parenthesis before the movable jaw represents that movable jaw is fixed. So I don't want to fix this. I want to float this. Say float. So you can move it now. Now I want to constrain, or I want to fix the base. So right click on this. So before that, I want to display the origins of all the parts as well as the origin of the assembly. So you can go to hide and show and you can activate this. So let us apply coincidence relationship between the origin of the base and the origin of the assembly. So press mate. So just select the origin of the base and origin of the assembly drawing document. So choose, you can check. So I want to pick coincidence. Say OK. Insert the handlebar assembly now. So I want to close this made property manager. Say OK. So I want to insert the, so you can browse it. I want to choose handlebar assembly. So let's select this and say open. So I want to place it here. Apply relationship between the handlebar and the base. So let us use mate. So I want to select the surface of this screw and the surface of the hole. So I'm choosing concentric and say OK. So if you want, you can move it. So still this can rotate, but so only the movement will be in the y direction. So now I want to have relation between the screw rod and this movable jaw. So let's select this. I want to select this edge and the edge of the hole. So let's select concentric and say OK. Rotate the assembly and just pick this surface. So say mate. So let's select this flat surface of the jaw and apply coincidence mate. Say OK. So if you see here, this movable jaw is actually rotating, which actually it shouldn't rotate. So I want to constrain the rotation of this movable jaw by just applying a parallel mate between this front face of the movable jaw and the front face of the base. So let's pick the, so I want to just fit this drawing here, sorry, the assembly here. So let's pick pick the front face of the movable jaw and the front face of the Y's. So by default it is picking coincidence, so practically it is not possible. So I want to pick parallel and say OK. Just zoom out. So let's apply relationship between the screw and the movable jaw. So I want to select the outer surface of this movable, the screw and the surface of this hole. I want to apply concentric. Say OK. For my convenience, I want to make this movable jaw transparent. So right click on this. So before that, let's close this property manager. So I'll say OK. So right click on this and you can choose change transparency. So now all the features which are hidden now, they are visible to us. So what I'm going to do is I want to apply a tangential relationship between this flat face of the screw and this cylindrical surface of the screw rod. So let's click mate. So let's pick this flat surface of the screw. So let's zoom out. So I want to pick this surface and I'll apply tangential and say OK. You can close the property manager. In order to insert the other screw on this side, I want to use mirror. So you can just click mirror components option. So here I'm choosing the right plane as the mirror plane, right plane of the movable jaw as the mirror plane. So you can select the movable jaw and select right plane. Okay, and in case of components to mirror, I want to select the screw. So you can pick screw from this feature manager, or you can pick it from the graphic window. So let's close this, say OK. So now, this is fixed. For my convenience, I want to make this vise transparent. So right click on this and you can choose change transparency. I want to apply a limit mate so that I can restrict the movement of this movable jaw. So let's select, so let's zoom out. So let's select this flat surface of this screw and the top surface of the vise. So automatically it is picking coincidence, so I don't want to apply coincidence relation. So let's move to advanced mates here and click distance. So move the property manager to the side. So you can just decrease the distance here. So I want to make it as 0 first. So if you see here, I want to leave some clearance. So here both surfaces are actually having that they have a contact. So I want to leave some clearance here of 1 mm. So just allot a value of 1 mm here. So I want to define this as the minimum value. So let's pick this, say 1 mm. So let's zoom out. So I want to have the front view of this. So you can press Ctrl 1. So I want to move this. So here I want to increase the distance. So make it 40. So still this movable jaw can move in the upward direction. So this top face shouldn't interfere with this surface. So I want to increase the value here, say 45. So I want to keep some clearance here, so I'm allotting 45 as the maximum value, and I'm keeping 1 mm as the minimum value, and you can close this limit made, say OK. So I want to close this property manager, say OK. So let's zoom out, and if you see here, so the movement of this movable jaw is restricted, and the movable jaw is not interfering with the vice base. I want to apply a screw mate, so let's select this curve surface of this screw and the curve surface of the hole. So let's pick this surface. So actually it is not possible to pick the inner surface of the hole, so right click on this and say select others. So now, so you can select this face. So the screw mate option is available under mechanical mates, so you can select or activate this screw mate. So here I want to go for distance by revolution option, and I want to say, so distance moved per revolution as 3 mm, and you can say OK. So just say OK. Let us see how the screw mate works. So you can just rotate this screw, and if you see here, for one revolution, actually the movable jaw is moving along the y direction of about 3 mm per revolution. With this, we complete the assembly of the pipe vise. So if you want to have different front view, side view and top view, so you can just simply, for front view you can hold Control and press 1. For side view, Control 3, and for top view, Control 5. So and for to represent the isometric view, you can hold Control and press 7.